the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on the videos.
Hi guys, welcome to another tutorial of Smart BU Kite on the course Telecommunication Engineering 1. In our last class, we derived the Fourier pairs, which is the Fourier transform and the Fourier series. So if you have not watched the video, I advise you to go and watch the video because it is very related to this. Now we are going to be solving questions on Fourier transform. For more subsequent videos, please subscribe to our YouTube channel and click the bell icon for you not to miss out on any video that we are going to be uploading. So here we are having a question. Consider a finite energy non-periodic waveform f of t with a rectangular pulse duration of t over 2, 0, t over 2. So the waveform is between, so what this is trying to say is the waveform is between minus t over 2 to t over 2 and an amplitude of v. So our waveform is having an amplitude of v. Determine the relative frequency distribution and hence draw the spectrum. So for you to solve this question, it's very simple and straightforward. It's very easy. So firstly, let's draw our waveform. So solution. So drawing our waveform. So we are told that this is it is a rectangle. So let's say here is minus t over 2 and here is t over 2. So it is having an amplitude of v. So let's call this place v. So this is our amplitude. So this is our waveform. This is what we are going to be having. This is what we are going to be having. Please don't mind my drawing. This is a rectangle. This is a straight line. This is rectangle. So now this is f of t. This signal is f of t. So it's still the same thing. So now we know that from our previous class we derived a formula. We said f of omega is equal to integral of infinity to minus infinity f of t exponential minus j omega t dt. So this is called Fourier transform, right? From our previous class. This is our Fourier transform. So this is our Fourier transform formula. This is what we are going to use to find the frequency distribution. So now applying this to what we are having here, we know that our f of t here is simply v. So now f of omega will be equal to integral of, so now our limit here is defined. It is finite, not infinite. Therefore it does not tend to infinity. Here we are having minus t over 2 and here we are having 2t over 2. So instead of putting minus infinity to infinity, we are going to put t over 2 to minus t over 2 to t over 2. So we said our f of t is v exponential minus j omega t dt. So now integrating this, we have our f of omega is equal to, so if we integrate this, we know that v is constant. We are just going to be integrating exponential minus j omega t. So integrating minus j omega t, we know that this coefficient is going to come down, minus j omega open bracket, we are having v, right? So instead of putting, let's bring v outside, since v is a constant, v exponential minus j omega t, limit from t over 2 to minus t over 2. So this is also equal to v over minus j omega open bracket. So if you substitute our limit, we are going to have exponential minus j omega t over 2 minus exponential minus j omega t over minus t over 2. So this minus can cancel this minus, so we are going to be left with j omega t over 2. So this is what we are having. This is what we are having as our expression. So now bringing this negative inside, because we want our expression to be neat, bringing this negative inside, we are going to have v over j omega open brackets. So if this should multiply this, that means this one is going to be positive, here is going to be positive, and here is going to be negative. So bringing this here, we are going to have exponential j omega t over 2 minus exponential minus j omega t over 2. So now for you to simplify this, we have to go back to our Euler identity. So from Euler identity, we know that exponential plus or minus j theta is the same thing as cos theta minus j sine theta. And we also know that if we are having an expression sine theta is also the same thing as exponential j theta minus exponential minus j theta all over 2j, and cos theta is equal to exponential j theta plus exponential minus exponential minus j theta exponential minus j theta all over 2. So this is gotten from Euler identity, and it has also been proven. So we can utilize this in our equation, since we are having something related to this. Here we are having j, and here we are having exponential j omega t over 2 minus j omega t over 2. So we are going to manipulate this equation for us to utilize this. So now, further simplifying, we can say f of omega is equal to v over, let's bring in j into the equation, so we can say v over omega open brackets exponential j omega t over 2 minus exponential minus j omega t over 2 all over j, right? This the j we brought out. So in mathematics, whenever we want to manipulate, we can multiply our equation by 1. So multiplying it by 1 means, if we said 2 divided by 2, this is still the same thing as 1. So we can have v over omega open brackets exponential j omega t over 2 minus exponential minus j omega t over 2 all over. So now if we multiply these two, let's bring this 2 to this place. Let's put our 2 here, and let's put the other 2 here. So this is still the same thing as this. So now you can see that this looks like this. This is related to this because our theta is equal to omega t over 2. If you look at this equation very well. So now we can further simplify our equation too. We can say f of omega is equal to 2v over omega. So instead of putting this, since we said our theta is equal to omega t over 2, so we can say sine omega t over 2. So now you see that we have simplified our equation using the Euler identity. So now we have to further manipulate this equation for us to be, because we want to plot the frequency. So we have to further manipulate this equation. So now, further manipulating this equation, we can say f of omega is equal to v over omega over 2. So this is the same thing as this, because these two will come up if we want to simplify it. So it's still the same thing. It's still the same thing as this. So now sine open bracket omega t over 2. So now let's further manipulate this. Let's say multiply by t over t, because the reason why we are further manipulating this is because we want to simplify our equation to something having sinc, because sinc sine x over x is equal to sinc x. So if we have something that, if we can be able to divide this entire equation by, if we can be able to divide this sine omega t over 2 with omega t over 2, we are going to have sinc x sin omega t over 2. So that's what we are trying to do. So multiplying this by t, now we are going to have something like this. F of omega will be v all over. So now v times t is vt. Let's call it vt. So now this t will multiply this omega. We are having omega t over 2. So now you see that we have achieved our aim, sine omega t over 2. So this is the same thing as vt sine open bracket, omega t over 2 all over omega t over 2. So now you see that we have manipulated this equation. This entire part of the equation is the same thing as sinc. So now f of omega is equal to vt sinc of omega t over 2. So now this is our expression. So now remember, in the question what are we asked to do? We are asked to determine the relative frequency distribution. So now for us to determine the frequency distribution, this is the expression to determine the frequency distribution. So now we are going to plot a graph. We are also asked to plot the spectrum, right? We are also asked to draw the spectrum. So for us to draw the spectrum, we have to bring out our ranges of frequency and plot the spectrum. So now it's very simple. What we are asked to do is we are going to define omega and f of omega. We are going to define omega and f of omega. So we are going to assume when omega is a value, sinc of minus 3 pi is 0, because here we are talking of pi is 0. So this is how we are going to be finding different value of omega. We are going to fill in this graph. So take a pen, take your pen and paper. So fill up this entire graph. Here we are taking the range from minus 6 pi over t to 6 pi, from minus 6 pi over t to 6 pi over t. So you are going to plot this range. You can take any range, it depends on you. So you are going to take any range. So let's assume we are taking this range. So here I've already taken my own ranges, I've already done my own assignments, so you can go and do yours. So these are my f of omega when omega is minus 6 pi over t, so up to 6 pi over t. So you can take any limit you want. You can start from minus 3 pi over t to 3 pi over t. So I recommend you take a distance, a range that is at least 3. So now let's check our waveform. So I've already plotted my own waveform also, so you can just plot yours too. So this is my f of omega, sorry, this is f of omega, and this point is the omega. So you just take your ranges since you've plotted. So you can decide to put mine, I use number here. You can use yours as minus pi over 6. It depends. If you plot this on your calculator, it will give you different thing as a number. So here we've come to the end of this tutorial. I hope you understand this. I hope now you can be able to solve questions regarding Fourier transform. In our next tutorial, we'll be solving the one that tends to infinity. So you are going to see how it's being solved. So stay tuned. Don't forget to subscribe to our YouTube channel. If you are confused or you have any question to ask, or you have a particular question you want me to make tutorials on, you can put it on the comment section. Thank you very much, and we'll meet in our next tutorial.